Welcome back to Unifi Experts Corner. I'm Spencer. In this episode, we're going to examine the factors that influence connection performance, then use this information to help you establish proper bandwidth and speed expectations. First, it's important to clarify how wired and wireless speed characterizations differ. Ethernet connections, for example, are specified as full duplex. A typical full duplex gigabit link can simultaneously pass 1 gigabit per second of download and upload traffic, totaling 2 gigabits per second of bidirectional throughput. Wi-Fi connections are specified in terms of one-way airspeed. As your wireless device sends and receives packets of data to a nearby AP, each packet carries a payload and overhead for the 802.11 protocol to communicate. Payload is usable data, and overhead is the instructions needed to transmit. Ethernet speeds are specified as just these payloads in both directions, which is why when you use gigabit Ethernet, you expect a gig and get a gig. Wi-Fi speeds take into account the complete frame, where only about half is a packet's payload of usable data. The rest is just overhead that is not. This is why Wi-Fi devices typically only deliver a fraction of their advertised maximum speeds, or 50% at best. A Wi-Fi link's maximum speed is determined by 4 factors: its standard, MIMO chain count, channel width, and signal strength. To illustrate, let's use a U6 Pro AP and an iPhone 13 Pro. If the iPhone sees the U6 Pro on channel 36 with a 160 megahertz channel width and has a strong signal, the link will utilize the Wi-Fi 6 standard. But the iPhone will only be capable of 2x2 MIMO. This scenario reflects the performance of a single isolated Wi-Fi link. But what do things look like on a more complex enterprise-level Wi-Fi network that supports multiple links? To find out, let's return to our aforementioned Ethernet connection. When multiple wired devices are connected to an Ethernet switch, each one will be able to achieve their max speed simultaneously. Wi-Fi devices, however, must wait in line to utilize their respective AP. Consequently, the weakest device will drag down the entire network's performance. Newer Wi-Fi standards have focused on overcoming this challenge by using MIMO chains to ensure that APs can serve multiple devices at once. To give your unified network the best wireless experience, we recommend a few things. Implementing higher order MIMO. Our U6LR, our U6 Pro, and U6 Enterprise APs all have 4x4 MIMO configurations. Being mindful of your channel width. Where wider channels can maximize speed, narrower channels provide greater stability. As such, 5 GHz radios and Unifi APs have a default channel width of 40 MHz, 20 MHz for 2.4 GHz radios. And finally, adopting enough APs to ensure that all of your devices have a strong signal. The Wi-Fi Insights tab in your Unifi network application can quickly give you an idea of where you need to deploy more APs. That should give you some clarity on Wi-Fi performance and a few factors that affect it. Join me next time on Unifi Experts Corner, where we will tackle another network challenge with the end goal of simplifying IT. Thank you.